So in this video, we'll look at question 8 from the practice exam. We're given two vectors, and we're asked to find the unit vector normal to the plane of that these two vectors actually exist in. So if you have arbitrary vectors in 3 dimensions, whichever way they're going, they actually form a plane. And if you want to find an expression for the unit vector that's perpendicular to that plane, normal and perpendicular, that's another way to say it, you want to use the definition that when you're finding the cross product of two vectors, it's always perpendicular to the plane that those two vectors form. So basically the first step is we're going to compute a cross product of these two vectors, and then we're going to normalize it in order to find a unit vector. So hopefully everyone remembers that in order to compute a cross product of two vectors in 3 dimensions, you form a 3 by 3 matrix where the first row is simply your unit vectors, I hat, j hat, and k hat. The second row is the rectangular components of A, so 14, 15, and -9. And the third row is the rectangular components of B, 9, -4, and -5. Looks like I have a little bit of a typo in this. I'll fix it and rescan it. But the key point is once you're actually doing in order to determine the cross product, you need to do a cofactor expansion along the first row. So if you have any questions how to do this, feel free to send me an email or go back and watch those videos. But basically, when you're computing the I component, you cover up the first row, cover up the first column, and you just deal with this little 2 by 2 matrix here, 15, -9, 4, and -5. And again, that's a little bit of a typo, which I'll correct before I actually post these. But when you're determining the J component, cover up the second column and cover up the first row, of course. And remember that when you go from I to J, that actually becomes a negative as well. Finally, to determine the K component, cover up the third column and the first row, and you're dealing with this little 2 by 2 matrix. I'll go through and compute what that resulting cross product is. And then once you have it, simply normalize by its actual magnitude, which you can find by taking the square root of the sum of the squares.